Hello science fans and welcome to SHE-ensya. Today, we continue our topic on life tables and population growth. To get some context for today's discussion, let us first discuss the history of human population growth. The first human populations on the planet were early hunter-gatherers. They are believed to be nomadic that led them to having a strong sense of the earth. They are highly familiar with the earth's natural cycles, the locations of certain species of animals that they hunt, as well as the different growth patterns of plants that they consume. Back then, the population sizes of humans were very small, but it is still up for discussion if the birth control then was intentional or circumstantial. There were certain traditional practices that allowed for abortion and other methods of birth control. Life then was very hard, so the growth of populations then could be controlled by the circumstances that our ancestors were dealing with. The lifestyle of our ancestors changed drastically when we learned to grow our own food. With the rise of agriculture, mass extinction occurred of other organisms due to predation and alterations of their habitat. However, it was necessary for the survival of the human species to cultivate their own food, mostly because their population rates increased to a point that they no longer could be supported by the natural production of food of the ecosystems they inhabited. The development of agriculture led to an abundance of food, and this led to a production of wealth, which led eventually to the formation of cities. The formation of cities was brought about by a separation of sites to where humans lived. Often, food was produced in the countryside, but it was consumed in aggregations of the human population that were called cities. Because of this, food wastes were no longer returned to the soil, and therefore, the soil in the countryside became less productive. Apart from that, the waste was concentrated in cities, and this led to a natural decline of cleanliness. But apart from that, people were also noticing that the populations were growing fast, and this also led to infanticides in certain populations. If they knew that they couldn't support the presence of a new child, some societies allow for the killing of newborns, while other societies preferred to only have one specific sex of children and therefore kill off children that do not meet this criteria. Medieval societies then were rich, however, it was also a dark time for the human race because of the presence of disease. With agriculture also came an abundance of time. People did not have to spend their whole day hunting and gathering for food. So suddenly, we had time to develop technology. And this led to industrialization. And during the early phases of industrial growth, children were viewed as a cheap source of income and cheap labor. And this led to an exponential growth of populations because the more children you had, the more income you had, and the more food you had. However, by the 1900s, the birth rates in industrialized nations dropped because of the rise of standards of living. Safe and inexpensive means of birth control were also introduced, and an increase in the cost of child rearing was observed because now children were no longer viewed as a part of a labor force, but as the future of a society that needs to be nurtured. But if you look at the history of population growth of the human race, we can see that the Industrial Revolution allowed for the fastest growth of the human population. Since then, we have been trying to control the growth of the human population because we are now fully aware that we have gone beyond the carrying capacity of the planet. There is a clear pattern between the population growth between less developed and more developed countries. We can see that less developed countries have higher population growth rates than those that are less developed. And this is mostly attributed to a lack of available materials for birth control, as well as imperfections in how the people are taught about birth control. Current world population is around 7.5 billion individuals. We are growing at a rate of 2.3 persons per second, 8,343 persons per hour, 200,234 persons per day, and 73 million persons per year. Of course, this can be affected by the current pandemic that we are all experiencing. The growth and decline of human populations and populations of other organisms of the planet are usually controlled by three things. This would be fertility, mortality, and migration. Fertility is defined as the ability of female individuals in the population to give birth. Mortality, on the other hand, is how many of the organisms die per generation and at what age. Migration is the ability of the members of the population to move from one location to the next and settle in the next location that they found. Populations in different locations are often characterized by age structure graphs. Age structure graph shows the proportion of individuals in each age group of a population. This can provide us information if the population is expanding rapidly, slowly, or if it is stable or declining. Let us now look at some examples of age structure graphs. If you look at the illustration behind me, you can see that a pyramidic structure such as those found in the Philippines, Guatemala, Nigeria, and Saudi Arabia show us an expanding population. These populations expand rapidly because they have a higher number of the younger members of the society compared to those who are older. A slightly less steep pyramid, on the other hand, such as those found in the United States, Australia, and China, show us populations that are expanding slowly. They also have a higher number of individuals at the pre-reproductive stages, but it is growing a little less fast because of the relative proportions of individuals at the reproductive and post-reproductive ages. Then, you have the stable populations of Japan, Italy, and Greece, where the graph is almost rectangular in its shape. There is almost an equal number of individuals at the pre-reproductive ages as well as the reproductive ages. And over time, of course, individuals in the post-reproductive ages go down. Examples of declining populations would be Germany, Bulgaria, and Russia. And here you can see an almost inverse pyramid wherein individuals at the pre-reproductive ages are actually present in smaller numbers than those in the post-reproductive ages. These different types of populations react differently to different environmental changes, such as the presence of pandemics and diseases. When it comes to COVID-19, it seems to hit countries that have a higher number of post-reproductive individuals because they are more vulnerable to the virus. And you can see that these countries have a more difficult time in controlling the virus. Apart from the use of age structure graphs, how do we know if a population will remain stable over time? A key aspect in managing ecosystems is in knowing whether a population will remain stable. These information can be acquired from life tables. Specifically, age-specific rates of survival and fecundity can be used to predict the growth or decline of populations. So it's time for us to do some math again, this time starting with net reproductive rate. Net reproductive rate, or R0, is computed by summing up the products of standardized survivorship and fecundity, or age-specific fertility. This formula applies in the assumption that survival and fertility schedules remain constant over time, although this rarely happens. If your net reproductive rate is greater than 1, then this implies that your population will grow exponentially. If your net reproductive rate is less than 1, then it implies that the population will shrink exponentially. If it is close to or equal to 1, then the population size will not change over time. And this means that the population size is stable. If we're concerned about long-term changes in the population, then we can look at the value of small letter r. Small letter r refers to intrinsic rate of increase, and to compute for it, we have to first compute for the g value, which is computed for in the formula shown in the background. You often divide the summation of the product of standardized survivorship, fecundity, and age of the organism by the product of standardized survivorship and age-specific fertility. The second part that allows us to get the R value is to use the formula in part 2. Now, the intrinsic rate of natural increase, or R, is the average rate of increase per individual and is the mathematical equivalent of average number of births per individual per unit time minus the average deaths per individual per unit time. The concept of R frequently becomes clearer only after we get to plot the equations using the term. When conditions are ideal, population increase is said to be at the biotic potential or maximum increase per individual. This is closely related to the concept of carrying capacity, which is the maximum number of individuals a particular habitat can sustain. Any reproduction above the carrying capacity will result in an equivalent amount of mortality. For natural populations, the carrying capacity of a habitat is often, but not restricted to, the amount and quality of food it produces. Life table graphs, especially those linked with intrinsic rate of increase, help us determine if policies that are targeted to control population growth are effective or not. If you look at the graph behind me, you can see that by changing fecundity schedules or adjusting survivorship, population growth can increase or decrease. The UN median projection shows us the expected population growth of the human species. If the universal two-child family policy is implemented, wherein families are only allowed 2 children, then you can see that it will taper over time. On the other hand, if universal one-child policies are implemented, we can actually see a decrease in population size by the year 2200. So I hope you're able to learn about the value of creating life tables and monitoring population growth and response. If you have any questions about this topic, please don't hesitate to let me, your resident Filipino scientist, know in the comments section below. Please like this video for more science goodness. Please don't hesitate to subscribe to our channel also. Thank you very much and see you around!